morning, afternoon, Algebra 2 crew. And what I'm doing is looking at 8-7, working on a couple of questions to give you the opportunity to see it done if you need assistance. So question 15 on page 456, this is section 8.7. It says to study how high a ball bounces, students drop the ball from various heights. The function h of t gives the height in feet of the ball at time t measured in seconds, since the ball was dropped from a height of h sub 0. The ball is dropped from a height of h sub 0 equals 8 feet. Write and solve an equation to find the elapsed time until the ball hits the floor. So looking at the question, you might not know where to start or how to solve it. And so what I did was I just read the question and used direct substitution. The starting height that the ball was dropped at was 8 feet. And so h sub 0 is 8 feet, and so I substituted. So my new function is here. And then instead of using t for time, I had to use x, since I have a GeoGebra file here. It only takes x as a variable for your graphing, x and y. So I plug that in. Now my function is h of x equals negative 16x squared plus 8. I wanted to see what that looked like and see if it helped me solve the question, since I was, a little confused. So I graphed it using GeoGebra, changed the scale, and you'll notice that my h of x axis measures the height of the ball. And so the starting height at 0 seconds, you see that, is 8 feet. That's this point right here. Now, it makes no sense to look at negative seconds, so the left-hand side of the graph here is ignored because it doesn't make sense to have negative time. So it's called the domain of the function, starts at 0 seconds and moves to the right. So the ball is dropped at 8 feet. And you'll notice that time marches on. And the ball, this isn't the path of the ball per se, but it's the height of the ball at a given time. You see that? So the height of the ball is changing. And if I were to draw a horizontal line here, representing the height of the ball, see it? Where the horizontal line intersects the parabola tells you the height of the ball at a given time. Now, eventually the ball is going to hit the ground, right? At what time? Well, the x-axis is the time, and so the ball will hit the ground right there. Looks like slightly beyond 0.7 seconds. So I see now what's going on. I kind of get an idea of what the question's asking. I understand that this function, if you graph it, it's a parabola, and that it measures the height of the ball given a specific time. Okay? And so it says to use algebra to solve this, so I think I can do that. Let's try it. By the way, this is called the x-intercept of a parabola, and the way you find the x-intercept of a parabola is you solve it by factoring or by using square roots or completing the square or quadratic formula. We're going to use square roots to solve this. And so given that, now I will solve it using algebra. So here's my first step. The height of the ball must be 0 when it hits the floor. When does that happen? And so h of x, the height of the ball, equals 0 feet. When does that happen? So we're setting our function equal to 0. Okay, set our function equal to 0, and this looks familiar. It's the standard form of a quadratic, setting it equal to 0. Now we can solve this by using square roots, since that's the subject of 8.7. Square roots, using square roots to solve quadratics. So I will subtract positive 8. Okay, so that's a little different. Normally we try to factor the quadratic, set it equal to 0. I'm using this technique first. So this becomes negative 16x squared equals negative 8. Now, don't take the square root yet. You must divide by negative 16. One step at a time to isolate the variable x. So it's going to be positive, and I'm going to reduce it. 4 divides into 8 twice. Actually, 8 does go into 16. So it's positive 1/2. Okay, now, let's give ourselves some room here. Let's take the square root of either side. And so now we have x equals plus or minus the square root of negative 1/2. Now, without complicating things, I'm now going to use the definition here and explain that x is either square root 1/2 or x is either negative square root 1/2. Okay? So it's either positive or negative. Now, again, we said x represents the time. And there's no such idea here in terms of a negative time. So this question here, this answer to the question, is ignored. So I wonder what the square root of negative 1/2 is. Well, my suspicion is that it might be a little beyond 0.7. So let's take my calculator and find out. Okay? Plug that into a calculator here once. So this should show up on the screen, I hope. So the square root of 1/2. Well, 1/2 is 0.5, so let's view this as a scientific. And the square root button is, don't see it, so I will use what we call fractional exponents. So the square root is the fractional power 1/2, so I'll write 0.5 raised to the 0.5 power. And there it is. I know it's tough to see, but it is 0.707. That's pretty close to 0.7. So this is about the value for x here. Use the decimal approximation is, let's round it off to the nearest 3 digits. So a little less than 1 second is when the ball will hit the ground. Okay, I hope that helped. That was just section A. It wasn't section B or C. And I'm hoping this will get you started on the right track so that you can solve sections B and C. Okay, like I always say, study hard and learn a lot. And we'll see you soon. Bye-bye.